So let's talk about. So we have done one part of it, which is discovery. Let's talk about the build part of it, right? So typically, what we do is start once great, you have discovered all the assets, you have TGWs running, you have VPCs, VNets, bunch of these things. How do I build this? How do I connect all these resources to your transit? How do I make sure that you have different type of apps and networks? They are running in like hundreds of these subscriptions. We have actually this customer itself, they are running more than 400 plus subscriptions in AWS.
Yeah.
We have seen 1400 plus subscriptions in AWS. Some people are just kind of going with one application per VPC. The whole VPC is kind of tied to, let's say, a BU. So multiple BUs, multiple subscriptions. How do you kind of, at scale, you can connect and build resources? Brownfield. So we want to make sure when we were building and designing this architecture, it has to be very, very brownfield ready. When I say brownfield ready, it means that it's easier for a customer to migrate from their existing deployment to Prosimo. So we made sure that all these components that we bring in, it is kind of covering the main brownfield migration aspect of it. I'll cover that in a bit as well. And then some advanced networking challenges that we typically see, like, for example, overlapping IPs. One of the biggest issues for people who have mergers and acquisitions, you have business partner connecting to your applications. They are connecting with the same RFC19 IP address, RFC1918 IP addresses. You are running the same RFC1918 IP addresses. How do you make sure that these resources can talk? I mean, you have to have some level of abstraction so that a source IP cannot see a destination IP. How do you make this kind of segmentation? What are the concepts that you use? So we'll go some of that in the demo part of it. But somebody asked a question about AWS RDS. Classic example, all of these different PaaS services, they constantly change the IPs. Whether it's every 24 hours, 48 hours, 76 hours, doesn't matter. They change IPs. How do you keep, if you're running at a routing layer, how many times you keep and updating your firewall rules or your route tables with all these ever-changing IPs? So what are we doing with that? So we'll cover all of these build aspects in the next level of demo, where we go through a concept of a service core, where we generate like these linked local IPs attached to a DNS. So even if the IP behind a target DNS, let's say for RDS, is changing, from the source side, it's still talking to that linked local IP. So we kind of do some logic and science behind to make these kind of use cases work for a brownfield environment. The part that Jyoti was talking about and Gaurav was talking about, let's take a typical example of two different VPCs and two different VNets. Now you have subnet 1, subnet 2, subnet 3, all across like in different type of VPCs and VNets in both the regions. Essentially, if you are working with a traditional or maybe other kind of some vendors, what they do is that you have to bring in the entire VPC and attach to it, which means I'm going to go and then change the routing for this entire VPC. So all the traffic should come to us. There is no way that I can say I do not want subnet 2 and subnet 3 to be attached. I just want, I want the entire VPC to be attached to our Prosimo fabric. So what we are essentially doing is that we have introduced a concept of a network. Now, it's not a network, if you will, like from a classic network perspective, but it's more of a logical construct that we have built in the platform, just like similar to namespaces. What it does is that it groups these subnets together. So let's say in a previous example, if I say I also only want to pick network 1 and network 2, I can call that as a network, right? So subnet 1 and subnet 2 will be part of network 1. Subnet 1 and subnet 3 will be part of network 2. So I can actually segment my VPC and then attach it or name it as network 1 and network 2, and then I can bring it onboard it to Prosimo fabric. This way, the routing information or the data paths that we are bringing up with Prosimo, it's only going to attract the traffic from these subnets. The rest of the VPCs will be untouched. This is very, very important for some of these migrations where somebody already has everything running. They have TGW attachments, VPCs are all attached. They said, we do not want to disrupt our production traffic. How easy it is that we can onboard some of these subnets to you just to make sure that everything is working before we go with the actual change management. That's where the entire concept of building these transit using a visual transit builder that Gaurav just displayed kind of dividing and segmenting these VPCs into multiple subnets and which subnet you want to onboard first when you are onboarding something to Prosimo. And then once you prove the value that this is all working, I've taken care of all of this, you can simply kind of apply the same networking abstraction to all of these different subnets. This will also help in policies. Let's say pick up an example of BU1 and BU2. I have dev, QA, and prod applications. I can create a network for dev. Now, all these subnets that can span across multiple VPCs, I can put them together into one network one, which means that I can apply the same compliance policies, any type of like governance rules, any of those type of things to only network one, which is spanning across multiple VPCs in maybe in different regions. So very strong concept, and some of the customers actually love it that they can, let's say if they are moving from an existing environment to Prosimo, or they want to apply certain kind of granular rules based on the function, the org function instead of a VPC layer, they can use this logical concept or a construct to apply these. On top of that, it sits a global namespace, what Gaurav talked about. So namespace kind of works globally. You can put a bunch of these prod networks, network 1, network 2, network 3, into one, which is probably prod or QA, and then assign them to a namespace. So they share the common kind of routing information and routing profile. So we'll walk you through some of these concepts as part of our next demo before we get to the actual segmentation and the visibility aspects of it.
One thing that did come up a couple of times, and as I'm a marketer and also a semantic nerd, so the fact that we have to say we use namespace and network in an environment where namespace and network have very different meanings, I would suggest maybe call it like the Prosimo, aggregate network, or the Prosimo namespace, because we, depending on where we come from, actually have a firm attachment to what that means. Not that I'm saying you don't already have customers that get that, but it's when you have to say not that kind of namespace, it would be interesting to sort of like label it so that it was identified differently. If that makes sense, and I don't mean it as a.
We are hearing it for the first time. I'm just.
Yeah.
I have heard it many times before.
So the compromise, the easy product compromise event, we called it a network namespace because we understand that application namespace are fundamentally different things, right? Yeah. They are a different abstraction construct. So we call it a network namespace, and network because it's the classic sort of segmentation object, right? And what we are trying to do here is essentially club subnets together and free them sort of from the cloud native segmentation construct, which is essentially a VPC or a VNet or an account, right? Essentially club these subnets together and treat them in a uniform manner. What is the off-the-shelf outcome you get? These subnets inside these different VPCs can talk to each other. You can enforce the same policy on top of this network object, right? Imagine doing that again on sort of a, in either a cloud native console or with something else, right? There are taxes you have to pay. You're either paying heavy instrumentation tax, or you're paying some sort of an appliance tax. So I can only make this happen if you're running, a V router or some object inside these VPCs.
At each point, it might be a giant VPC with a whole bunch of applications. I want to create this logical objects, bunch of.
Oh yeah, no, totally. It's conceptually it's easy. It's just one of those things like when the name, when you say the name and then you immediately have to say the caveat for why it's named this way, but not quite what you think the name is going to mean.
It's not obvious.
Yeah, like the product explanation is snap right on, and it's just the fact that you call it the same as something else.
Awesome. Yeah. So in this part of the demo, what I'm going to focus on is we've been talking about attach these networks or connect these networks to the fabric. How do we actually do that? And I showed you a while ago. I showed you this discovery piece, right? This is one objective of discovery is to see what is there, get the lay of the land. But the other objective of the discovery is, if at all I choose to attach this or connect this network to Prosimo, how do I go about it? So I have chosen this particular VPC, just let's say we want to attach it to Prosimo Fabric, right? I click on onboard, I give it some name. It's in this region, and maybe let's say I want to give it some names, and this is the namespace here. Where do you want to put it? Do you really want to segment this traffic? They are not pre-built. You can actually create these namespaces. So you have network segments where you want these constructs to be attached so that you can define a security boundary around them. I'm just going to put it in this and hit submit. Now, what happens under the hood is it's going to
pop up all the information, all the intelligence that Prosimo has about this VPC, and it will give it for you to review before we finally onboard it, right? So it's telling you, hey, this is in this public cloud, there are this account, this region, this is the VPC you have chosen, here is the Prosimo components connectors that are running. And now, here is the point where Prosimo discovered that here are the transit gateways that are actually sitting in your AWS account. Which transit gateway do you want us to attach, use, basically? So let's say customer says, I want to use this one. You could have chosen any one. And then we click on proceed. This is where it says attach a policy. As I said, we follow the philosophy of trust nothing. So I'm not going to attach any policy. And I'm going to click on proceed. And from there on, it says go and onboard. Onboarding means attaching this to the fabric. Now, what is happening under the hood? What you can do is you can go into this task section and click on this and see what Prosimo is doing. What we are actually doing is we are trying to find out, hey, is there an existing underlay that exists? If it does, I'm going to use it. If it doesn't exist, I'm going to build it. So that's the first thing that happens. We are going to make sure that we go into that VPC and any existing networking construct and we update your route tables, because now the traffic should flow through Prosimo. So that happens as a part of network onboarding. We also make sure that if at all there is any policy that is there, it should make sure that the policy is attached to this route table update. And in the end, what's going to happen is we will show you. It's going to take maybe a few seconds, but this will come up here. Right now, it's 57%. But essentially, when the onboarding is done, that means this VPC or this particular network is attached to this Prosimo fabric. Right? So this is on the network side. I let it run, but we said, okay, you know what? It's not just about networks. You can also bring in your services or your applications. What does that process look like? And I'll just walk you through one of the services that I have onboarded. So I have this Azure PostgreSQL database that is a managed service by Azure. What I've done is when you are onboarding or attaching it to Prosimo, it gives you an option. Hey, what kind of service is it? Is it a TCP UDP protocol, FQDN? Is it a web app? It's a DNS service, or is it a cloud platform service? Let's say you have an S3 bucket. You can actually attach an S3 bucket to the fabric itself. And then we ask you, okay, what FQDN is it using? What protocol is it listening on? If at all you know, tell us which cloud is it in. Because it's an Azure service, you will tell us, okay, this is in Azure. And then a few other things, right? Optimization. How do we actually intelligently route the traffic? And then if you want to attach any policy to it, I already have one policy. And then you go ahead and onboard. It goes through the same process. Now, the good thing that happens is that it's not just about one type of application. You can go and bring any type of application. We can actually discover these applications as well. So I can go ahead and discover these applications. If the applications are registered with the IDP, you can just sync your IDP with Prosimo. If you can integrate with any service discovery offering out there. And once we talk to that, we will ingest all these. We will actually not onboard it, but at least we'll show that, hey, these are the services or applications that are sitting there. If you wish, you can go ahead and onboard all of these services, right? So this sort of becomes a central repository of all these services and applications that you can attach to your fabric, and your clients or networks, whoever wants to access them, they can actually access it. And in this case, it doesn't matter where that service is. That's the agnostic part of it. Your service could be running in data center, or it could be running in Azure, GCP, AWS. It doesn't matter. At the same time, your source also can be anywhere. And now they are attached to the fabric. It's routable. And the next thing that's going to happen is, okay, you showed us how do you attach. Should they be talking to each other? So I have this 1077 already onboarded. This is what we were just doing. It says
I just want to highlight the two quick points here. While he was discussing all this, you know what happened, right? So he onboarded something. So in the background, we not only spin up, let's say if there is a TGW there, we spin up a TGW attachment. If it's an Azure vWAN attachment, we kind of orchestrate the route table, have the route pointing back to Prosimo, make sure all the services are up and running and healthy, and then onboard this network. So this all happens like within probably like 2 minutes of his talk track. So consider this, that if you're working with a very large environment, just like, for example, for this healthcare, many of these networks are well distributed across multiple VPCs, VNets, different cloud providers. How many times you have to log in, make sure there is a route entry or there's a UDR created, there is a security group that got opened up. It's a very, very complex task. And it's in just a matter of probably few minutes, we were able to onboard the network, attach it to a Prosimo, make it part of a policy that already has few applications attached in this demo example, and everything is up and running.
And just before I move to a different topic, I just wanted to show that you can go ahead and attach overlapping networks as well. We actually give you an idea of, let's say you've onboarded these hundreds of networks to this Prosimo fabric. Hey, show me where, if at all, I have an onboard, I have actually overlapping and where they all are. So you can just come here. I just clicked on this view overlapping networks and will actually show you that, hey, here in this particular, this VPC and this subnet is actually overlapping with each other. So that's what's happening. Now, if you see here, this is, my policy says implicit deny, right? So now let's say that I already have a couple of other sources. This guy is also onboarded, same thing in AWS. And if I go here and try to, let's say, ping this guy, should it work? And again, as I've been saying, our philosophy is trust nothing, right? Because there is no policy attached to it, even though they are in the same network segment, they cannot talk to each other. So the question is, let's say I have a prod namespace / network segment. I have 10 VPCs and VNets that are part of it. Are they, just because they are in the same network segment, should they be talking to each other, right? And we think they should not be, unless and until you show the intent or you specify the intent that they should be talking to each other. You also have an option, like if at all, let's say, even we go to customers and they say, you know what, this is good network segmentation, but we first want to get this up and running and we'll figure out the policy part later. You can also say, I want to put everything in a single network segment, just use allow all network policy, and then everything can talk to everything, and we'll, as we start migrating to you guys, will define the policy. But I think in the right, if you're deploying it with the right architecture, the security is going to be the integral part of how you are building this whole network architecture, right? So right now, the traffic is not going to work because there is no policy attached. And before we go to the security side where we are going to show it, we showed you.
So just a quick question. So again, ICMP is one thing. So right. When you're saying it's not talking to each other, there's really no protocol that is allowed.
No, everything is blocked unless you explicitly allow it as part of the network policy.
Correct.
And you do get that fine-grained control, right? Because your particular TCP application or network could be hosting workloads and certain things. But still, full-fledged policy.
Yeah, and I'll show it too. I'll show it that unless and until you specify it, it wouldn't work.
Maybe